Our universe is a story where each new discovery rewrites the last chapter. We are about to explore 25 of the most mind-bending space phenomena recently found, cosmic clues that challenge our understanding of physics and set our imaginations on fire. By the end, you'll be looking at the night sky in a completely new way. How can a star simply vanish for months? What force could throw a supermassive black hole clear out of its galaxy? Which of these cosmic mysteries makes you question everything you thought you knew? Our universe just revealed a ghost, a structure so vast it defies easy comprehension. Astronomers have discovered a giant radio galaxy they call Alcyoneus, and it currently holds the title as the largest known structure of galactic origin in the entire cosmos. Picture the most colossal thing you can, and then multiply it by a scale that is almost meaningless to the human mind. This galaxy's radio lobes, immense plumes of energetic particles, stretch across an astounding 16 million light-years of space. To put that inconceivable distance into perspective, our own Milky Way galaxy is a mere 100,000 light-years wide. Alcyoneus could swallow 100 of our galaxies lined up in a row. These colossal lobes are not made of stars, but of a thin, magnetized soup of plasma, glowing not in visible light but in the long waves of radio energy. They act as a fossil record, a lingering echo of incredibly violent eruptions from the galaxy's central supermassive black hole, activity that happened millions of years ago. The greatest mystery is not just its size, but its existence. How can such a delicate, filamentary structure remain coherent over such unimaginable distances and timescales? What specific conditions in the intergalactic medium allowed Alcyoneus to grow to this unprecedented scale, where others have fallen short? This cosmic ghost challenges our models of how galaxies interact with their surroundings, a silent leviathan hiding in plain sight, forcing us to reconsider the true limits of cosmic structure. While cosmic ghosts like Alcyoneus stretch the limits of size, another discovery reveals a drama of pure cosmic violence. The Hubble Space Telescope has captured something that should be impossible, a supermassive black hole, an object with the mass of 20 million suns fleeing its home galaxy at tremendous speed. It is not moving through empty space, however. Streaking behind it is a narrow, brilliant corridor of newborn stars, a stellar wake stretching over 200,000 light-years long. This is not the empty trail of a retreating monster, but a river of creation left in its chaotic path. The likely explanation is a gravitational event of almost unimaginable power. Picture 3 supermassive black holes, each the heart of a merging galaxy, caught in a frantic dance. As 2 of them spiral together and merge, the tremendous energy released can act like a cosmic slingshot, violently flinging the third black hole clear out of the galactic core. This is not a gentle nudge, but a catastrophic ejection, sending the behemoth careening through the halo of its own galaxy. The real magic happens in its wake. The black hole, moving at hypersonic speeds, plows into the thin gas that surrounds the galaxy. This gas is compressed, shocked, and forced to collapse, igniting the fires of star formation in a straight, narrow line. We are witnessing a rebel engine of creation, a destroyer that paradoxically forges new suns as it escapes. This single observation shatters the old, quiet image of a sedentary black hole sitting placidly in a galaxy's center. It reveals a universe where these gravitational titans are in constant, dynamic motion, capable of being thrown from their thrones. What does this mean for the evolution of galaxies? If black holes can be so easily evicted, how many other galaxies have lost their central hearts, left to drift as dark, starless husks? This runaway behemoth is a testament to the chaos of cosmic mergers, a literal trail of evidence pointing to a violent, formative event that reshaped an entire galactic system. But what if the first stars were not stars at all? We are now peering into the universe's deepest past with the James Webb Space Telescope, and it is showing us objects that should not exist. Brilliant, massive galaxies are shining in the cosmic dawn, far too early and far too bright for our standard models to explain. One radical solution proposed by astrophysicists is that we are not looking at galaxies, but at the first true monsters, theoretical objects known as dark stars. These are not the dim, cold stars you might imagine from the name. A dark star would be a behemoth, potentially millions of times more massive than our Sun and orders of magnitude brighter. Its power source would not be the nuclear fusion that fires our own Sun, but something far more exotic and pervasive, the annihilation of dark matter. Picture the core of a normal star, a seething furnace where atoms of hydrogen smash together to create helium, releasing light and heat. Now replace that entire engine. At the heart of a dark star, theoretical particles of dark matter would meet and destroy each other, their mutual annihilation releasing a continuous, overwhelming flood of energy. This process would keep the gaseous giant puffed up and stable for millions of years, preventing it from ever collapsing enough to ignite conventional fusion. It would be a star that runs on the universe's greatest mystery. The recent James Webb observations of impossibly early, luminous objects are the first tantalizing clues that these dark stars might be real. If confirmed, this would completely rewrite the first chapter of cosmic history. The very first lights in the universe may not have been fusion-powered suns, but dark matter reactors, shining with the energy of invisible particles. This forces us to ask a profound question. Is dark matter, the unseen scaffolding of the cosmos, also capable of building its own celestial lanterns, illuminating the darkness from within? From the universe's first potential stars, we now turn to a frozen titan from our own cosmic backyard. A visitor has entered the inner solar system, and it is rewriting the book on what a comet can be. This is Comet Bernardinelli-Bernstein, the largest comet humanity has ever laid eyes on. Its icy heart or nucleus is estimated to be over 80 miles wide. To grasp that scale, picture the famous Halley's Comet and then multiply its nucleus by 10. This is not a speck of dust glowing with a temporary tail, but a substantial planetary body in its own right, a primordial iceberg on a grand tour. Its journey is as epic as its proportions. This megacomet originates in the Oort cloud, a distant, spherical shell of icy objects that forms the outermost boundary of our solar system. It has been falling sunward for millions of years, and its recent pass through the inner system is merely a brief blip in an orbit so long it defies human comprehension. It will not return for several million more. What makes this object so special is its pristine state. Having spent almost all of its existence in the deep freeze of the Oort cloud, it has been perfectly preserved since the solar system's birth. Studying it is like opening a time capsule that dates back 4.5 billion years. Its chemical composition, the structure of its ice, and the dust locked within its core are direct samples from the era of planet formation. By analyzing this frozen leviathan, we can answer fundamental questions. What were the original building blocks of the giant planets? Did comets like this one deliver water to the early Earth? Every observation is a clue to our own origins, a piece of the puzzle explaining how a cloud of gas and dust transformed into the vibrant system we see today. This colossal wanderer is a reminder that our solar system is not a finished portrait, but a dynamic museum, still capable of sending its most ancient artifacts right past our doorstep. That ancient comet is a local relic, but our solar system has also received visitors from much farther away. We have been struck by a meteor from another star. In January 2014, a small object slammed into the Earth's atmosphere over the South Pacific, creating a brilliant fireball. At the time, it was just another logged event by United States government sensors. Years later, however, astrophysicist Amir Suraj and his colleagues, while poring over that data, made a stunning realization. This was no ordinary space rock. Named CNEOS 2014-0108, this meteor was moving at over 30 miles per second relative to the Earth. That incredible speed was the key clue. Its trajectory was not a closed loop around our Sun, but an open-ended hyperbolic path. The math was undeniable. This object was not from our solar system. It was the first known interstellar meteor to ever strike our planet, predating the famous interstellar visitor Oumuamua by more than 3 years. It was a tiny messenger from another star, and it had delivered its message in a flash of light and energy. The scientific implications were so profound that it sparked a real-life treasure hunt. A subsequent expedition, led by Professor Avi Loeb, traveled to the calculated impact zone off the coast of Papua New Guinea. Their mission was to dredge the ocean floor 2.4 kilometers down in search of the meteor's fragments. They recovered hundreds of tiny, molten spheres, smaller than a millimeter across. The initial analysis suggested a composition tougher than any known iron meteorite from our own solar system. This is where the mystery truly deepens. The scientific community is now locked in a vital debate. Are these exotic fragments truly from that interstellar object, or could they be common volcanic dust or even debris from human industrial activity? Their unusual strength hints at a material forged in an environment unlike anything we know. Could it be a piece of an exoplanet, or perhaps even something artificial? The quest for answers continues, a deep-sea detective story searching for physical proof that we are not alone in the galaxy, and that pieces of other worlds are already here, waiting on our ocean floor to tell their story. Deep within the dusty heart of our galaxy, a new class of cosmic elders has been found, behaving in a way that defies all expectations. Astronomers have identified ancient red giant stars, which they have nicknamed Old Smokers. These stars are in their final stages of life, having burned through their primary fuel, and for decades they appeared quiet and stable. The breakthrough came when surveys monitoring the galactic center noticed something bizarre. Over periods of months or even years, these seemingly placid stars would suddenly dim, their light fading dramatically as if a veil were being drawn across them. The cause was not a distant planet passing in front, but the star itself. These old smokers were belching out colossal clouds of dust and gas, shrouding themselves in a self-made cosmic fog. For a long time, they had been hiding in plain sight, their slow, rhythmic cycles of dimming and brightening mistaken for data errors or other, more mundane stellar activity. The process is a strange and violent form of stellar digestion. Deep within the star's turbulent outer layers, conditions are just right for tiny solid particles to condense out of the cooling gas, like soot forming in a smoky flame. These particles are then carried outward by powerful stellar winds, creating a vast opaque screen that blocks the star's light from our view. Eventually, the cloud dissipates and the star brightens once more, only to repeat the process years later. This peculiar behavior is more than just a stellar curiosity. It is a vital piece of the galactic recycling system. The dust these stars puff out is not simple soot. It is stardust, rich with heavy elements forged in the star's core over billions of years. Elements like carbon, oxygen, and iron are carried within these clouds and eventually seeded into the interstellar medium. This enriched material becomes the raw ingredient for new stars, planets, and even the building blocks of life itself. These quiet, elderly stars are therefore cosmic farmers, patiently tending the galactic soil. They are a fundamental source of the complex chemistry that makes our own world and potentially other worlds possible. This discovery forces us to ask how many other such stars are out there, silently puffing away, and what role their gentle, rhythmic exhalations have played in building the chemically rich universe we see today. This planetary paradox has a name, TOI 5205b, and its very existence breaks the rules. Imagine a gas giant roughly the size of Jupiter, a behemoth of a world, but instead of orbiting a sun-like star, it circles a small, cool red dwarf. This star, TOI 5205, is a cosmic lightweight, only about 40% the size of our own Sun. The visuals here are staggering. Picture Jupiter, a planet so large it could swallow over 1,000 Earths, orbiting a star that is barely 4 times bigger than the planet itself. In this system, when the planet passes in front of its star during a transit, it blocks a staggering 7% of the star's light. This is not a subtle dip, it is a celestial blink, as if someone turned a dimmer switch on and off. Our own Jupiter, transiting the Sun, blocks only about 1% of its light. The sheer scale of this eclipse is what first signaled to astronomers that they had found something truly bizarre, something that should not be. Conventional wisdom in planet formation states that a star births its planetary children from the disk of gas and dust that surrounds it in its youth. A small, cool star like this one would have a correspondingly small, anemic protoplanetary disk. There simply should not have been enough solid material, enough building blocks, in that tiny disk to assemble the core of a gas giant, let alone the entire colossal planet. It is like expecting a small backyard garden to produce enough soil to form an entire mountain. This discovery forces a fundamental rethink. Did this planet form elsewhere and somehow migrate inward, a theory that comes with its own set of dynamical headaches? Or did it form through a different, more rapid process altogether, one we have not yet considered? TOI 5205b is a forbidden planet, a cosmic rule breaker that proves our textbook models of planetary birth are still missing crucial chapters. The universe's quiet giants are not the only ones sending messages. From the depths of intergalactic space comes a signal so powerful it outshines entire galaxies, and one of them has been caught pulsing with a steady, rhythmic beat. Astronomers have detected a fast radio burst, an FRB, originating from a galaxy billions of light-years away. These bursts are themselves a major puzzle, immense flashes of radio waves that last for just thousandths of a second, releasing in that blink more energy than our Sun emits in 3 days. For years, most of these were one-off events, cosmic flashbulbs that popped and vanished forever, leaving no clue to their origin. But this particular burst is different. It repeats, and its repetitions are not random. They follow a precise, predictable cycle, rising and falling with a clear period like a cosmic heartbeat. The signal pulses with a regularity that is both mesmerizing and deeply revealing. The period of this cycle is incredibly long, stretching over many months. For about 2 months, the source is active, sending out its brilliant millisecond flashes. Then, for the next 67 days, it falls completely silent, only to switch on again with clockwork precision. This regular on and off pattern is a vital clue etched into the fabric of space-time. The leading theory points to an extreme binary system. Imagine a highly magnetized, rapidly spinning neutron star, a pulsar, locked in a slow, wide orbit with a massive companion star. As the pulsar travels along its elongated path, there are periods when its powerful beams of radiation, which sweep through space like a lighthouse, are pointed away from us. Then, as it swings around in its orbit, its beams align with Earth for a couple of months, and we see the brilliant flashes each time one sweeps past our line of sight. The incredibly long orbital period suggests the companion object could be another neutron star, or even a black hole, circling each other in a slow gravitational waltz. This heartbeat in the data is more than just a curiosity, it is a key. By studying the precise rhythm of this and other repeating bursts, scientists can begin to rule out cataclysmic one-time events, like a star being shredded by a black hole, and focus on the complex physics of these enduring, dynamic systems. What kind of object can survive the forces required to produce such staggering energy bursts over and over again, for years on end? This rhythmic enigma brings us one step closer to understanding the violent, magnetic hearts of the universe's most energetic objects. That steady cosmic heartbeat is a sign of order, but our hunt for worlds beyond our solar system has just uncovered a potential companion in the darkness. Astronomers believe they have found a moon orbiting a planet in a distant star system. This candidate, known as Kepler 1708 b, would be only the second exomoon ever discovered, and it is a whopper. The data suggests a world the size of Neptune, a gas giant in its own right, circling a planet far larger than Jupiter. The evidence was not captured in a photograph, but was painstakingly extracted from years of old data from the Kepler Space Telescope. Kepler hunted for planets by watching for the subtle, periodic dimming of a star's light, a telltale sign that a planet was transiting or passing in front of it. To find a moon, scientists had to look even deeper. They searched for additional, much smaller dips in starlight, either just before the main planet's transit began or just after it ended. It is the celestial equivalent of detecting a fly buzzing around a distant street lamp by the tiny flicker it causes in the lamp's glow. This is what the team found in the light curve of the star Kepler 1708. After the giant planet itself had finished its transit and the star's light had returned to normal, there was a second distinct dimming. This faint signal is the signature of the moon candidate trailing behind its host planet, like a child following a parent through a doorway. The statistical analysis is complex, and the scientific community continues to debate the finding, but the potential is immense. Why does the search for exomoons matter so much? In our own solar system, moons like Europa and Enceladus, with their hidden subsurface oceans, are considered some of the most promising places to look for life. A giant moon orbiting within the habitable zone of its star could have an environment all its own, a world with two horizons in its sky. Finding Kepler 1708 b, if confirmed, would do more than just add a new moon to a catalogue. It would throw the doors wide open to a whole new class of worlds, suggesting that moons around giant exoplanets could be common. We would no longer be searching for just alien planets, but for entire alien planetary systems, complete with families of moons, each one a potential haven in the vast, cold space between the stars. Even the smallest worlds can hold monumental surprises. As NASA OSIRIS-REx spacecraft descended toward the asteroid Bennu, its cameras revealed a tiny companion, a moonlet just a few meters across, affectionately nicknamed Dinky, gracefully orbiting its parent rock. Here was a mini solar system in its purest form, a clear challenge to our assumptions. How could an asteroid so small, a mere rubble pile about 500 meters wide, possess enough gravity to hold onto a moon? The answer lies not in brute strength, but in a delicate balance. Bennu is not a solid chunk of rock. It is a loose collection of boulders, gravel, and dust, held together by the most feeble of forces, van der Waals and electrostatic cohesion. Its gravity is so minuscule that an astronaut could easily leap from its surface and escape into space forever. In such an environment, the escape velocity is a mere few centimeters per second. For Dinky to remain in orbit, it must have been placed there with incredible gentleness, likely born from a slow, low-energy collision or ejected from the asteroid's surface without ever achieving enough speed to break free. This discovery is a profound window into the internal structure of these primordial objects. The very fact that Bennu can hold a moon tells us its components are weakly bound, a collection of building blocks that have clung together for billions of years. The stunning images and video from OSIRIS-REx show a world where pebbles and boulders litter the surface, a landscape so loosely packed that it resembles a child's ball pit more than a solid planet. This changes our entire understanding of how planets are born. The first planetesimals, the seeds of worlds like Earth, may not have been monolithic rocks, but fragile aggregates of dust and ice, their weak gravity just enough to gather more material. Dinky is more than a curiosity. It is a direct observer of that ancient process, a tiny moon teaching us that the foundations of our entire world were built on the faintest of cosmic handshakes. A galaxy sparkling with the light of ancient fires has appeared in the early universe. The James Webb Space Telescope has spotted a system so distant we see it as it was 9 billion years ago, a cosmic toddler by the standards of the universe. Yet this young galaxy, aptly nicknamed the Sparkler Galaxy, is not a blank slate. It is already adorned with dozens of brilliant points of light, dense clusters of stars that astronomers believe are infant globular clusters. These are not the faint, aging clusters we see in our own mature Milky Way, but stellar nurseries in their fiery prime, captured at the very moment of their formation. This is like finding a photograph of a grandparent as a newborn baby, holding a family heirloom that is even older than they are. The sparkles themselves are a direct window into the universe's first great wave of star formation, a chance to see the processes that built the first galactic structures. For decades, the prevailing model held that galaxies built up slowly over time, accumulating stars and clusters through a long, gradual process of mergers and steady star formation. The Sparkler Galaxy shatters that timeline. Here is a galaxy seen in its relative infancy that has already assembled a magnificent collection of ancient stellar jewels. It matured at a breathtaking speed, reaching a level of complexity and structure that we thought took billions of years longer to achieve. The very existence of these dense, bright clusters so early in cosmic history forces a dramatic rewrite of our galactic evolution models. How did it happen so fast? What violent, rapid conditions in the early universe could forge such brilliant structures in a geological instant? The Sparkler does not just show us a young galaxy, it shows us a precocious one, challenging our most fundamental ideas about how the cosmos grows up. Some stars do not simply drift through the galaxy, they flee it. Astronomers have discovered pairs of stars, binary systems locked in a mutual gravitational dance, that are racing through the Milky Way at millions of miles per hour. These are hypervelocity binary stars, and their incredible speed is so great that they are destined for one final, lonely journey, to escape the gravitational pull of our galaxy entirely and vanish into the intergalactic void. Their origin story points to a single, terrifying engine at the very heart of the Milky Way. The leading theory is that these stellar pairs had a close, disastrous encounter with the supermassive black hole, Sagittarius, a star which lurks in our galactic center. In most cases, a star wandering too close to such a monster would be torn apart. But for a tightly bound binary system, the encounter can play out like a cosmic game of gravitational crack the whip. As the pair swings near the black hole, its immense gravity can rip one star away, capturing it into a tight orbit. The other star, in a violent transfer of energy, is then slingshotted away at an astonishing speed, a celestial projectile flung out of the galactic core. The true marvel is that some of these binaries survive the ordeal intact. Instead of being torn apart, the entire pair gets a gravitational kick so precise and powerful that it is ejected as a single unit. This requires the black hole's tidal forces to act on the binary system as a whole, a delicate maneuver that sends both stars flying away together, still gravitationally bound on a one-way ticket out of the galaxy. How can a partnership survive such a violent divorce from its home? The key lies in the precise trajectory and speed of the encounter. If the binary swings by the black hole on a very specific path, the gravitational energy stolen from the black hole's rotation is transferred to the pair's orbital motion, boosting their velocity without necessarily pulling them apart. It is a testament to the bizarre precision of orbital mechanics, where chaos and order can coexist for a fleeting moment. These runaway pairs are more than just cosmic curiosities. They are living proof of the dynamic violence occurring in our galaxy's core. Each hypervelocity binary we detect is a fossil record of a past encounter with the supermassive black hole, a natural experiment that tests the limits of gravity itself. Their very existence helps astronomers map the invisible gravitational landscape of the Milky Way's central region, tracing the footsteps of a gravitational giant we can never see directly. These cotton candy worlds defy every instinct we have about what a planet should be. Imagine a gas giant like Jupiter, but with the density of a sugary dessert, so incredibly puffy that its atmosphere is little more than a wispy veil. This is the reality of a class of exoplanets, with Kepler 51b as a prime example, that possess densities literally comparable to cotton candy. A planet like this is a giant without substance, a cosmic paradox floating in space. How can such a world hold itself together against the vacuum? The leading theory points to internal heat as the inflating force. These planets orbit very close to their parent stars, and the intense stellar radiation likely traps enormous amounts of thermal energy deep within their cores. This heat acts like a furnace, causing the entire atmospheric envelope to swell up like a hot air balloon, bloating the world to a tremendous size while its overall mass remains relatively low. Another possibility is that these planets accumulated vast amounts of the lightest gases, hydrogen and helium, in their youth, but never developed a massive, dense core to anchor them. They are all atmosphere, a fluffy, distended cloud of gas barely bound by gravity. Studying them is a unique challenge. Their incredibly extended, hazy atmospheres make it difficult for our telescopes to peer down to any potential solid surface, if one even exists. When we try to analyze their composition by observing starlight filtering through their air, the signals are often muted and confused by the very puffiness that defines them. Yet, their existence is a crucial data point in the grand census of planetary diversity. Our own solar system, with its neat division of small, rocky worlds and large gas giants, now appears to be just one possible outcome. The cosmos has a far richer palette, creating planets that are fluffy, dense, ringed, or barren. The cotton candy giants prove that the process of planet formation is capable of producing outcomes we once thought were impossible. Worlds that are not quite star and not quite planet, but something beautifully in between. Our galaxy is wrapped in a secret, invisible ocean. For the first time, astronomers have successfully mapped the immense halo of hot gas that surrounds the Milky Way, a discovery that may finally solve one of cosmology's most stubborn mysteries, the case of the missing matter. We have long known that the ordinary matter we see in stars and planets accounts for only a fraction of what the Big Bang should have created. The rest, the so-called missing baryons, was thought to be hiding in the vast spaces between galaxies. This new map suggests a huge portion of it has been right here at home all along, enveloping our entire galactic neighborhood. To create this map, scientists turned the universe into a giant shadow puppet theater. They used the brilliant, distant lights of quasars, the active supermassive black holes at the centers of other galaxies, as cosmic backlights. As the light from these quasars traveled for billions of years to reach us, it passed through the Milky Way's diffuse halo. Specific wavelengths of this light were absorbed by the hot, ionized gas in the halo, primarily oxygen atoms that have been stripped of several of their electrons. By analyzing the unique fingerprints of this absorption in the spectra of dozens of quasars, the research team could triangulate the density, temperature, and distribution of the halo's gas. The resulting three-dimensional map revealed a structure of astonishing complexity and scale. This is not a simple, smooth sphere. The galactic halo is a turbulent, lopsided ocean of plasma, with swirling currents, vast bubbles, and towering filaments of gas stretching for hundreds of thousands of light years. Some regions are dense and opaque, while others are startlingly thin. The temperature is staggering, soaring to millions of degrees, which is why this vast reservoir has remained invisible to optical telescopes. It glows only in high-energy X-rays. The sheer mass of this hidden ocean is the key to the mystery. The data indicates the halo contains more material than all the stars in the Milky Way combined. This single structure could account for a huge fraction of the universe's missing ordinary matter, finally balancing the cosmic books. This discovery transforms our understanding of the galaxy's life cycle. This halo is not static, it is a dynamic, breathing entity. It acts as both a reservoir and a recycler, capturing gas that falls in from intergalactic space and expelling material blown out by supernova and galactic winds. The fate of our galaxy is written in the swirling patterns of this invisible sea, a map not just of what is, but of what is yet to be. Deep within the silent fabric of the cosmos, a persistent hum has finally been heard. This is the gravitational wave background, a low-frequency rumble in the very structure of spacetime, recently detected for the first time by a global network of radio telescopes using pulsar timing arrays. Think of the universe not as a quiet void, but as a vast, crowded stadium, each pair of supermassive black holes spiraling together in the final dance before a cataclysmic merger creates its own distinct rhythmic ripple in spacetime. Individually, these events are too distant and their frequencies too low for us to pick out a single one. But together, across billions of years and countless galaxies, their overlapping signals create a constant collective choir, a background hum that fills the entire universe. It is the sound of cosmic history itself, the accumulated echo of every galaxy that ever merged, a fossil record written not in stone, but in the vibrations of reality. This discovery confirms a fundamental prediction of Einstein's theory and reveals a universe teeming with these gravitational titans. The sheer strength of this hum tells astronomers that mergers between galaxies and their central black holes are not rare, catastrophic exceptions, but a standard part of galactic life. Our own Milky Way is on a collision course with the Andromeda Galaxy, and in several billion years, their supermassive black holes will also spiral together, adding their own final note to this eternal cosmic chorus. What does this mean for the fate of galaxies? The gravitational wave background suggests that the growth of the largest black holes in the universe is driven primarily by these violent unions, rather than by slowly swallowing gas. This hum is the soundtrack to that growth, a direct line into the most powerful and enduring relationships in the cosmos. Long before the first planets formed, a star was born from the ashes of two different kinds of apocalypse. Astronomers have identified an ancient sun they call the Barbenheimer star, a cosmic fossil that tells the story of two unimaginably violent events that happened in quick succession. Its name is a playful nod to the dual nature of its origin, combining the contrasting energies of a neutron-star merger, an event of incredible density and nuclear force, with a supernova, a stellar explosion of pure destructive power. The evidence is locked in the star's very chemistry. This ancient object contains a specific, rare blend of heavy elements, including gold, platinum, and uranium. Some of these elements can only be forged in the extreme, neutron-rich environment of two colliding neutron stars, a process known as the rapid neutron capture process, or the R process. Yet, the star also contains a distinct signature of elements that are the hallmark of a classic core collapse supernova. The only way this single star could possess both sets of elemental fingerprints is if the cloud of gas it formed from was polluted by the debris from both a neutron-star merger and a supernova that occurred very close to each other, both in time and space. Picture the early universe, a chaotic and dark place. In one corner of a giant gas cloud, two ultra-dense stellar corpses spiral together and collide, spraying space with newly minted gold and radioactive elements. Then, almost immediately afterward on a cosmic timescale, a massive star nearby reaches the end of its life and explodes as a supernova, seeding the same cloud with a different suite of metals like iron and oxygen. Before the expanding debris from these twin cataclysms can dissipate, gravity pulls the enriched gas together and a new star ignites, its atmosphere a permanent chemical record of the violence that created it. This single star is therefore a time capsule from an era of cosmic chaos. It provides the first direct evidence that these two different types of cosmic explosions could work in tandem to enrich the galaxy, creating the complex chemical diversity that would later become the building blocks of rocky planets and ultimately life itself. The Barbenheimer star forces us to wonder how many other such dual-origin stars are out there, and whether this chaotic, double punch of creation was a common recipe for forging the elements that make up our world. Deep within the ice giants, a storm of precious stones rages eternally. Recent laboratory experiments have finally recreated the crushing conditions found inside planets like Neptune and Uranus, providing the strongest evidence yet for a long-theorized marvel, diamond rain. Scientists used powerful lasers or immense diamond anvil cells to subject a material similar to plastic, a simple hydrocarbon compound, to pressures millions of times greater than our atmosphere and temperatures of thousands of degrees. In this environment, the bonds between carbon and hydrogen atoms are violently shattered. The carbon atoms, freed from their molecular chains, are then squeezed together with such immense force that they crystallize into actual diamonds. These newly forged gems do not float, they immediately begin to sink, pulled by gravity down through the dense, slushy interior of the planet like a glittering, heavy hail. The process is a form of planetary alchemy, turning common chemical compounds into a shower of solid diamonds. This internal weather system is far more than a beautiful curiosity. It is a fundamental driver of the planet's very energy budget. As these diamonds fall through the thick layers of slushy ice and gas over thousands of years, friction from their descent generates substantial heat. This internal heating could be a crucial piece of the puzzle for explaining why the interiors of these distant, cold worlds are so much warmer than models predict from the sun's feeble radiation alone. This heat, in turn, churns the conductive fluids deep within the planet, directly influencing the generation of its bizarre and complex magnetic fields. Neptune and Uranus have magnetic fields that are tilted and offset from their centers, unlike the relatively orderly fields of Earth or Jupiter. The constant sinking motion of diamond rain stirring the planetary interior may be the chaotic engine behind these magnetic oddities. This transforms our view of these worlds from static, featureless orbs into dynamic planets with a rich and active inner life, where the very core is shaped by a continuous snowfall of carbon crystals. The diamonds sinking into Neptune's core are not the only strange particles falling through space. Far beyond our solar system, a different kind of rain is pelting our spacecraft, a shower of cosmic rays that carries a message we are only just beginning to decode. Instruments on board the Voyager probes, now in interstellar space, and the Alpha Magnetic Spectrometer mounted on the International Space Station, have recorded something deeply puzzling. They are detecting far more positrons than our models predict. A positron is the antimatter counterpart to the electron, a particle of antimatter that should be incredibly rare in the cosmos. The data does not show a random scatter of points. It paints a clear and rising curve on a graph. As the energy of these cosmic rays increases, the fraction of positrons amongst them also increases, peaking at a specific energy before tapering off. This is the heart of the anomaly, a signal that defies conventional explanation. If these positrons were simply byproducts of normal cosmic processes like supernova explosions, their numbers should fall with higher energy, not rise. This unexpected surplus is a clue pointing to a new, exotic source. The cosmic detective story begins with two primary suspects. The first is a pulsar, the rapidly spinning, magnetized corpse of a dead star. A nearby pulsar could act as a natural particle accelerator, whipping electrons and positrons to incredible speeds and flooding local space with them. Some astronomers have identified potential pulsar culprits whose estimated output and distance could account for the anomalous signal. The data, however, is not a perfect match, leaving room for a far more thrilling possibility. The second and more speculative suspect is dark matter. Theoretical physicists have long proposed that when two dark matter particles collide, they could annihilate each other in a flash of energy, producing a spray of standard particles, including electron and positron pairs. The specific shape of the rising curve in the AMS data, that peak and subsequent fall, could be the unique fingerprint of a dark matter particle with a specific mass. It could be the first indirect glimpse of the universe's most elusive substance caught in the act of destroying itself. This is where the mystery deepens into a true puzzle. The data is tantalizing but not yet conclusive. It is like having a fingerprint at a crime scene that matches two different suspects. We cannot yet rule out the pulsar explanation, and until we cannot claim a dark matter discovery. The hunt is now on for more clues. The search for even rarer particles like antihelium nuclei has begun. Finding just a single antihelium nucleus in cosmic rays would be a monumental event, as they are almost impossible to produce through standard astrophysical processes, but could be a clear product of heavy dark matter annihilation. Every new data point from the silent detectors in space brings us closer to answering one of cosmology's biggest questions. Are we seeing the aftermath of a stellar engine, or the first faint signal from the invisible 85% of the universe's matter? Jupiter holds a second great spot, a sprawling dark mark in the planet's shimmering upper atmosphere. But this vast feature is not a storm of churning clouds. It is a profound cold spot, a region of intense chill stretching nearly 15,000 miles across and lingering for centuries. While the Great Red Spot is a seething, warm anticyclone, a colossal high-pressure system rising from the deep interior, the Great Cold Spot is its polar opposite, a stable, frigid void hovering high above the North Pole. Its existence was painstakingly uncovered by astronomers analyzing years of infrared data, revealing a patch of the upper atmosphere that is consistently hundreds of degrees cooler than its surroundings. The source of this persistent cold is not a lack of sunlight, but the planet's own spectacular auroras. Jupiter's powerful magnetic field funnels charged particles toward the poles, where they slam into the atmosphere and generate a permanent, dazzling light show. This immense input of energy does more than just create pretty lights. It actually drives a massive system of energy redistribution. The auroral heating sets up a powerful flow in the upper atmosphere, a kind of planetary wind that pulls heat away from the region immediately surrounding the auroral oval. This creates a sustained, high-altitude vortex of cold air, a dark scar of frigid gas etched into the polar sky. Stunning composite images from the Hubble Space Telescope show these two great spots together, a testament to Jupiter's complex weather systems. One is a deep, warm, and ancient storm, the other a high, cold, and ethereal shadow. This discovery reveals a fundamental truth about gas giants. Their weather is not just a product of the sun's heat, but is also driven from within by powerful magnetic forces and the complex dance of energy between the poles and the equator. The Great Cold Spot is a window into the invisible forces that shape the atmospheres of worlds far beyond our own. A reminder that even the grandest features can be born from the subtlest of energy flows. A star can hold its breath for an entire season. That is the enigma of VVWIT-08, a colossal giant whose light was nearly extinguished, fading by a staggering 97% and remaining that way for months. This was not the gentle wink of a planet crossing a star's face, nor the slow pulse of a variable star. This was a celestial blackout, as if a cosmic hand had closed over the sun. The event was captured in the steady gaze of the VVV survey's telescopes, which recorded a light curve so dramatic it looks like a data error, a sheer cliff where the star's brightness simply drops off a cliff into nothingness. The graph tells a story of a slow, deliberate dimming over weeks, a deep, prolonged minimum that lasted for 200 days, and then an equally slow return to full luminosity. The leading theory paints a picture of a hidden dance between two cosmic bodies. The blinking giant is likely orbited by a smaller, unseen companion, perhaps another star or even a large planet, shrouded by a colossal, opaque disk of dust and debris. This is not a thin, elegant ring like Saturn's, but a vast, messy cloud of dark material stretching millions of miles across. When this dusty satellite passes in front of the giant star from our point of view, it blocks almost all of its light, creating an eclipse of a kind we have never seen before. The scale of this obscuring disk is what defies belief. For it to blot out 97% of the light from a star that is itself a behemoth, the disk must be incredibly dense and perfectly aligned with our line of sight. We are witnessing a cosmic alignment of breathtaking precision and rarity, a fleeting celestial performance that few generations of astronomers will ever see. The mystery deepens when we ask what could create and sustain such a vast shroud of dust. The companion object must be undergoing some form of extreme activity, perhaps continuous collisions between moons or asteroids in its system, or violent outgassing that continuously replenishes the dark, orbiting cloud. This blinking giant is more than a single strange star. It is a prototype for a new class of variable star, one defined by these extreme, dusty eclipses. How many other such giants are out there, silently winking in the darkness, their strange companions hidden by veils of cosmic soot? Each one is a testament to the chaotic and diverse ways that solar systems can evolve, hiding their greatest secrets in plain sight behind a curtain of dust. The sheer curtain of dust hiding a blinking giant is a gentle mystery compared to the raw, unfiltered violence of a stellar death scream. For the first time, astronomers have captured tera-electronvolt photons from a gamma-ray burst. A TV photon carries 1 trillion times more energy than a particle of visible light, a staggering amount of power packed into a single quantum of radiation. To find these photons arriving from an event billions of light-years away is like detecting the precise impact of a raindrop in the middle of a hurricane, a feat that seemed nearly impossible until now. This detection opens an entirely new window onto the final moments of a massive star. A gamma-ray burst is the universe's most powerful explosion, a focused blast of energy that outshines entire galaxies for a brief, spectacular moment. It is thought to be the birth cry of a black hole, formed when a rapidly spinning, massive star collapses. In that catastrophic instant, twin jets of plasma are launched from the poles of the dying star at over 99.9% the speed of light. These relativistic jets are the particle accelerators of the cosmos, and the TV photons are their ultimate signature. They are not produced in the initial collapse itself, but deep within the complex shock waves that ripple through these jets as they plow into the surrounding space. Imagine a cosmic tsunami crashing into the interstellar medium. The collision is so violent that it forces electrons to spiral along magnetic field lines at nearly light speed, a process called synchrotron radiation, which then whips them up even further in a second shock wave, producing the incredibly high-energy TV light. By analyzing this light, scientists can now peer directly into the heart of these shock fronts. The spectrum of the TV emission acts as a forensic tool, revealing the density of the material the jet is slamming into, the strength of the magnetic fields, and the exact efficiency of this natural particle accelerator. It tells us how the universe takes the raw chaos of a stellar collapse and focuses it into the most energetic beams imaginable. This is not just about understanding one type of explosion. It is about studying the fundamental physics of matter and energy under the most extreme conditions since the Big Bang itself. We are now reading the fine print of a stellar catastrophe, written in photons of pure, unimaginable power. Earth has a secret traveling companion. Astronomers have confirmed the existence of an object called 2020 XL5, a 2,000-foot-wide asteroid that shares our planet's orbit around the Sun. It is only the second known Earth Trojan, a cosmic hitchhiker locked in a delicate gravitational dance with our world. This asteroid does not orbit Earth directly, but instead rides steadily ahead of us, trapped within a special region of stability known as a Lagrange point. These points are like gravitational eddies in space, places where the combined pull of the Earth and the Sun creates a pocket of calm. An object placed there can essentially park itself, orbiting the Sun in perfect sync with our planet while using very little energy to maintain its position. 2020 XL5 is stationed at the L4 point, leading Earth in its journey by about 60 degrees. If you could look ahead along our orbital path, you would find it waiting there, a constant celestial sentinel. The reason these Trojans are so difficult to find is a matter of geometry and light. From our vantage point on Earth, these asteroids appear very close to the Sun in the sky. We can only search for them low on the horizon during a brief window of twilight before dawn or after sunset. Their faint, glimmering light must be picked out from an intensely bright background, a monumental challenge for even the most powerful telescopes. This confirmed discovery opens up thrilling possibilities for the future, because these asteroids are in such a stable and energetically cheap orbit to reach from Earth. They represent prime candidates for robotic exploration. A spacecraft would require minimal fuel to rendezvous with 2020 XL5, making it an ideal target for a mission. Scientists could study its composition, unlocking secrets from the early solar system, much like the asteroids in the main belt between Mars and Jupiter. But the vision extends even further. Some see these Trojans as potential stepping stones for deeper space exploration, or even as future sources of raw materials. The metals, water ice, and other volatile compounds locked within its rocky body could one day be harvested to build structures in space or refuel interplanetary missions, turning a cosmic companion into a celestial gas station. This silent partner sharing our road around the Sun transforms from a mere curiosity into a tangible resource, a piece of the solar system waiting just ahead of us in the orbital lane. A cosmic spider spins a web of pure radiation, patiently consuming its stellar partner. This is the reality of a black widow pulsar, a millisecond pulsar that has earned its terrifying name. These systems begin with two ordinary stars orbiting one another. One star is more massive and burns through its fuel faster, ending its life in a supernova explosion and leaving behind an ultra-dense, rapidly spinning neutron star, a pulsar. For a time, this stellar corpse is dormant, but the story is far from over. The system evolves and the companion star ages, swelling into a red giant. Its outer layers spill over, pulled by the intense gravity of the nearby neutron star. A river of stellar gas spirals down onto the pulsar's surface, a process that does two critical things. This incoming mass carries immense angular momentum, acting like a whip that spins the pulsar up to incredible speeds, hundreds of rotations every single second. It also transfers fresh matter, effectively recycling the dead star and reigniting its powerful magnetic fields. The pulsar awakens, no longer dormant but now a frenetic, spinning dynamo. It begins to blast its surroundings with two lethal forms of energy, an intense flood of high-energy radiation and a relentless wind of charged particles moving at nearly the speed of light. This onslaught directly strikes the surface of the donor star, the very same star that fed it and gave it new life. The effect is a slow-motion stellar murder. The particle wind and radiation bombard the companion, heating its surface to unimaginable temperatures and literally blasting its atmosphere away into space. We can see this directly as telescopes detect a vast, glowing cloud of evaporated material being blown off the star. The companion is being stripped down layer by layer, its mass steadily transferred and then violently ejected. In the most extreme cases, the entire star may be completely evaporated, leaving behind a solitary, rapidly spinning pulsar drifting through the void, a silent testament to its cosmic crime. The Black Widow has consumed its mate, leaving only the ghost of a binary system and a killer spinning alone in the dark. Our own galaxy holds the fossil of its own violent awakening. Stretching high above and below the Milky Way starry disk are colossal, radio-emitting bubbles, each one a towering structure of hot gas spanning 25,000 light-years from end to end. These are the Fermi and Erecita bubbles, a pair of cosmic balloons that dwarf every other structure in our galactic neighborhood. They were discovered by piecing together observations from two different space telescopes, one seeing the bubbles in high-energy gamma rays and the other in soft X-rays, creating a complete all-sky map of this breathtaking formation. The sheer scale is almost impossible to internalize. If our eyes could see in radio and X-ray light, this double-lobed hourglass would dominate the night sky, covering a region as wide as 50 full moons. The most compelling explanation for these titanic structures points directly to the dormant monster at the heart of our galaxy, Sagittarius, a star. Sometime between 6 and 10 million years ago, this supermassive black hole likely experienced a cataclysmic feeding frenzy. As vast clouds of gas and dust fell into its gravitational well, the black hole did not swallow all of it. Instead, it converted a portion of that immense mass into pure energy, firing twin jets of relativistic particles and intense radiation perpendicular to the galactic plane. This was not a gentle exhalation, but a violent bipolar outburst that punched through the Milky Way's own gaseous halo, inflating these colossal cavities and filling them with million-degree plasma and magnetic fields. The event would have been a brief but spectacular firestorm in the galactic center, a few 100,000 years of furious activity that left a permanent scar on the galaxy's structure. The discovery of these bubbles forces us to see our galactic home not as a stable, serene island universe, but as a dynamic and occasionally violent system. That ancient outburst would have sterilized large regions of the galactic center, scouring any fledgling planetary systems with intense radiation. It also redistributed energy and magnetic fields on a galactic scale, shaping the environment in which new stars would later form. This is our galaxy's history, written not in stone, but in the faint, lingering glow of a ghostly structure that has been hanging in space for millions of years, a permanent monument to a forgotten cataclysm. A galaxy does not need stars to exist. At the edge of our observational limits, astronomers have found the ghost of a galaxy, an object with the mass of a small dwarf galaxy like the Small Magellanic Cloud, yet it contains almost no stars at all. This candidate dark galaxy is composed almost entirely of dark matter, a shadowy structure revealed not by the light it emits but by the gravity it wields. Its discovery hinged on one of Einstein's most profound predictions, the gravitational lensing of light. The immense invisible mass of this dark galaxy acts as a cosmic lens, warping the fabric of space-time around it. When the light from a more distant background galaxy travels through this warped region, its path is bent and distorted. From our vantage point, that faraway galaxy appears stretched and twisted into faint, smeared arcs, a telltale signature of an unseen mass bending its light. By meticulously mapping these subtle distortions across the sky, astronomers could trace the outline and calculate the mass of the invisible lens, revealing the dark galaxy's hidden structure. This is not a void, but a place teeming with gravitational force, a phantom limb of the cosmos. The implications are staggering for our understanding of how galaxies are born. The prevailing theory suggests that all galaxies form within vast halos of dark matter, whose gravity draws in the gas that eventually coalesces into stars. This dark galaxy presents a profound puzzle. Why did this particular dark matter halo fail to light up? Did it form in a region of the early universe that was starved of the normal hydrogen gas needed to create stars? Or was the gas pulled in, only to be ripped away by a violent event or blown out by the feeble heating of the first stars? Perhaps it is a primordial fossil, a galaxy that never truly awakened, preserving the pristine conditions of the early cosmos. Its existence challenges the very definition of a galaxy, forcing us to ask if the true skeleton of the cosmic web is built from these dark, starless halos, with the shining galaxies we see merely the rare, lucky exceptions where conditions were just right. If this object is confirmed, it opens a direct window into the nature of dark matter itself. The way its mass is distributed could reveal whether dark matter particles are cold and slow-moving, or if they possess a tiny bit of intrinsic motion, a property that would affect how they clump together on the smallest scales. We are no longer just searching for what dark matter is, but also for what it builds. This dark galaxy is a silent blueprint, a map of the universe's invisible architecture waiting to be read. These 25 cosmic enigmas are a testament to a universe far stranger and more wonderful than we ever dreamed. From vanishing stars to forbidden planets, from diamond rain to an invisible ocean of hot gas, each discovery reveals a cosmos brimming with diversity and mystery. Some findings, like the gravitational wave background, confirm our deepest theories, while others, like the impossibly early sparkler galaxy, tear up the cosmic rulebook entirely. Yet whether they fit our models or shatter them, every single one pushes the boundaries of human knowledge a little further into the dark. They remind us that the universe is not a static museum piece, but a living, breathing, and deeply dynamic entity, constantly rewriting its own story. This journey of discovery belongs to all of us. The next time you step outside and look up at the night sky, remember that you are gazing into a frontier of ghostly giants, runaway black holes, and silent, dark galaxies. The greatest chapters are still being written. We want to hear which of these phenomena captured your imagination. Was it the ancient dark stars, the cosmic crime of the Black Widow pulsar, or the silent heartbeat of the repeating FRB? Share your thoughts in the comments below, and if you are hungry for more mysteries, be sure to subscribe and join us as we continue to explore the greatest story ever told.